chapter 2 was on the variation graphs, and there were four main ones, and the first one was y equals kx, which hopefully you remember is a line. So when we sketch those, a line just goes from the bottom left to the upper right, and then we also sketch the negative just so that we could compare, and I'll do all of my negatives in pink here, and I think you usually did yours in dotted lines so you could tell the difference. But either way, domain as we go left to right should be all reals. And range as you go from the bottom to top is also all reals. Okay, so if you're not sure about these on the test, you could always pick a number for k, so maybe you just pick 2, and then y equals 2x, and then you could just graph that on your graphing calculator and check. But I would think you would know what a line is. And hopefully you would know that y equals kx squared is a parabola. So parabola that opens up would be the positive one, okay, and then the negative one, which will again be my pink ones, would be one that opens down. No matter what parabola we're looking at, as we go left to right, the domain is still all reals because no matter what you put in, you get an answer out. But the range changes. So if we look at the positive one, which is my blue one here, then I would say I start to see it at 0 and everything above. So y greater than or equal to 0. And then for my k value, which is negative, which is the one that opens down, I would have y is less than or equal to 0. So I kind of color coordinated those so those make sense to you. Symmetry, both of them have y-axis symmetry. Okay, so they can reflect, and maybe I'll write reflection here for you, but reflection over the y-axis, as you can see, could fold itself right over. And then we had the two inverse graphs. Okay, remember inverse meant division, so the first one was called a hyperbola. Okay, and a hyperbola was in quadrants 1 and quadrants 3. So this is 1 and 3 here. Okay, the negative one switch quadrants. So the negative one would be in 2 and 4. And some of you got confused when we did these graphs. The 4 of those did not make one graph. Okay, the blue is one graph, which is positive, and then the pink or salmon there is the other graph. Okay, so those are two separate graphs. But either way, no matter which one we look at, as we go left to right, we are going to see that graph everywhere, but we are not going to see it at 0. Okay, it has a break in the graph. How I remember that is if you have to pick up your pen or your pencil to draw your graph, then there's a hole. Okay, and vertically, it is also at 0, so we're going to have x and y cannot equal 0. Asymptotes were those things where the holes existed. So this is a line where the graph does not cross or touch. So hopefully you can see here that that is the x and y axis. Okay? And then we also had the inverse square curve. So the difference here is it's k over x squared. And then the graph, the difference is now the branches are side by side. So the positive is in quadrants 1 and 2. And then the negative graph is in quadrants 3 and 4. Okay, so how I remember it is the x squared over here. The parabola had pieces side by side, and now so does the inverse. They're side by side. This one just has a break in it. So the domain, just like the hyperbola, is x cannot equal 0. The only difference is as our range is a little bit different. If you look at that blue graph, it's only above 0. So now the blue, oopsies, the blue graph or the positive graph is above 0, and then the negative graph, which is in quadrants 3 or 4, is below 0. Okay, because these branches are next to each other, they also do have y-axis reflection symmetry. Okay, and this also has x and y-axis for the asymptotes. Okay, so those are the basic things that we talked about in these graphs. So let's go ahead and move on to a different topic, which was just kind of variation in general. So question 1 says m is directly proportional. Directly, hopefully remember, is multiplication to the cube of n. So I'm going to write m equals kn to the third. And then m equals 24 when n equals 2. Okay, so the first step is to pause there and solve for k. So you plug in your n and your m, and 2 to the third is 8. So I divide each side by 8. So that's going to give me k to equal 3. Now I can solve my question. So I know k is 3, and then I want to know when n equals 4. So I'll plug in 4 to the third. So we should get a final answer of 192. Question 2 says y varies inversely. So inversely means divide. Okay, so those are your two terms for this chapter. So y varies inversely, so that equals y equals k over the square of x, so x squared. Again, you're going to solve for your k, so I'll plug in 4 for y and 5 for x. Now solving for k here is just a little different. This time I'm going to multiply each side by 25 because 5 squared is 25, so those cancel. So here k is going to equal 100. So now I can plug that back into my equation. I have 100 over x squared, and the question is find when x is negative 2. So negative 2 squared. Please notice I put my negative 2 in parentheses and my square on the outside because that should give me a positive 25 for an answer. Number 3 says consider y equals 2x to the fifth. If x is tripled, what happens to y? This is one of those top 10 most missed questions. So we'll think about a c and an n value here. So c is my change. Okay, so being tripled is my change. N is my exponent, so there I look at my formula, the fifth. I do not care about that 2 in front, okay, because that's there no matter what, so that doesn't change. So then my formula says find c to the n. So that's going to be 3 to the fifth, which is 243. This was an example of direct multiplication, so I'm going to say multiplied by 243 for my final answer. Okay, number 4, y varies inversely as the fifth power of x. So maybe I'll just jot down that formula. So inversely is divide by, and then the fifth power of x. So then it says if x is multiplied by 4, so that'd be my c value. My n is still my exponent, so that's going to be my 5. So c to the n will be 4 to the fifth. So that's 1024. And this time, because it's inversely, my answer is going to be divided by 1024. Okay, hopefully we remember those. So we'll try number 5. This is the kind of combination stuff where we had more than one thing going on. So 5a says z varies jointly as the square of x and the cube and y. Jointly meant all multiplication. Okay, so z varies jointly as the square of x and the cube of y. Just remember when you see the word varies, you also need to throw a k in there for your constant of variation. Letter B says m varies directly as n and inversely as the square of r. So if you see the word inversely, there's where you have your division sign. Okay, so if you forget what jointly means, like in part A, and you don't see the word inversely, then you never divide. Okay, so only when you see the word inversely do you divide. So let's try a story problem that goes along with that. An object is tied to a string and then twirled in a circular motion. The tension in the string varies directly as the square of the speed. Okay, so I've got tension equals the square of the speed and inversely as the radius. Okay, when the radius is 5, so plug in 5 for my radius, the speed is 4 feet per second and the tension is 90 pounds. So I plugged in all of those numbers for my variables and I have to solve for k. So what I suggest here is putting 90 over 1 and cross multiplying. So 90 times 5 is 450. 4 squared is 16, so I have 16k. So to solve for k, I would divide by 16 and I would get 28.125. Okay, so then I can rewrite my equation with my 28.125 in for my k. I need a new speed. So the question says if the radius is 3.5, so plug in 3.5 on the bottom, and the speed is 4.4, and then that still needs to be squared. Make sure to carry over, okay, all of your powers to all of these. Find the tension. So I'm going to do 4.4 squared times it by 28.125 divided by 3.5, and you should get about 155.7 pounds. Okay, try that on your calculators and make sure you can find that. Okay, and then 7 through 13 go back to those graphs that we sketched in the beginning and then seeing which ones were which. So which ones have a domain of all reals? Okay, that would be A and B. That would be your line and your parabola. Which ones have y-axis symmetry? That would be B and D. Okay, because B and D are the ones that had the branches right next to each other. The graphs are in quadrant 1 and 3 when k is greater than 0. So that means we're looking at these blue graphs, and then I'll just label those in case you forgot. So quadrants 1 and 3 would be graphs A and C, which have a range of y's less than or equal to, notice this equal to sign, when it's less than 0. Okay, that's going to be B. That's the only one that goes through 0, 0. Which ones have asymptotes? Said C and D. Okay, all the ones where you have to pick up your pencil to do so. Which graphs pass through 0, 0? That would be A and B. C and D do not go there. And then which graphs have points in quadrant 2 when it is k is greater than 0? So quadrant 2, that would make that B and D. Okay. And then one more for this chapter is to write the variation that fits both graphs. So hopefully you can see that this first one is an example of inverse variation. So that was usually y equals k over x or k over x squared. Okay. Here though we have g and h. So this is really going to be h equals k over g or over g squared without exact data points you could pick. But the second one is exactly a straight line, which would be y equals kx. Okay, if I write my variables, that's going to be h equals k times d. So now I have these two equations that have to go together. So if I kind of mash those together, I would get h equals kd over g. Okay, another viable option would be over g squared. Okay, so that is chapter 2.